And I'm glad I wrote notes because now I know where we last left off, and I really need to, I really want to finish this this chapter. I really want to finish this book. So let's do some review here first. So we're on the chapter about array-based sequences. So we know we learned that a byte is equivalent to 8 bits, and bits are like pieces of information. The memory address is an abstraction to keep track of what information is in what byte, and it's coordinated in a sequential fashion. RAM is an easy to access memory. It is just as easy to retrieve byte number this as it is to retrieve byte number that. The memory address formula is just the start plus the cell size times index. Why does that move here? To get around the problem of having cells of different length with no known maximums in an array and having the intention to not be wasteful with memory, Python just stores the memory addresses in the array which are references to the elements. This allows Python to achieve constant time access. None is also allowed. It's pretty simple stuff. So I have my ebook on another monitor. That's why you can't see it. But I can read it out loud. I don't know. So we're still on 5.2. Oh, I should probably start at tomato time. The fact that lists and tuples are referential structures is significant to the semantics of these classes. A single list instance may include multiple references to the same objects as elements of the list, and it is possible for a single object to be an element of two or more lists, as those lists simply store references back to that object. As an example, when you compute a slice of a list, the result is a new list instance, but that new list has references to the same elements that are in the original list as portrayed in figure 5. When computing the slice of a list, the new list instance has references to the same elements that are in the original list. When the elements of the list are immutable objects, when something like temp how do I do code block? Is executed, it doesn't change the existing integer object. It changes the reference in cell 2 of the temp list to the to reference of a different object. In case of immutable list objects. Immutable meaning you can't change. The same semantics is demonstrated when making a new list as a copy of an existing one, with a syntax such as backup equals list primes. This produces a new list that is a shallow copy and that references the same elements as in the first list, with immutable elements that point is moved. And if the contents of the list are of immutable type, a deep copy, meaning a new list with new elements. Okay, so shallow copy produces a new list that references the same elements as in the first list. Deep copy produces a new list with new elements. As a more striking example, it is a common practice in Python to initialize an array of integers using a syntax such as counters equals 0 times 0 to produce a list of. This syntax produces a list of length x with all 8 elements being the value of 0. Technically, all 8 element cells of the list reference the same object as portrayed in figure 5.8. So I guess it's just showing us some rules. As a final manifestation of the referential nature of lists, we note that the extend command is used to add all elements from one list to the end of another list. get 5.2.2 compact arrays. Strings are an example. A list. There's not references of a compact array. Because this array is storing the bits that represent the primary data. Because the array stores the primary data, not stores the bits that represent the primary data, not references. Compact arrays have several advantages over referential structures in terms of computing performance. Compact arrays have much lower overall memory usage. Uh, let's say we wish to store a sequence of 1,064-bit integers. They are also stored the primary data in compact arrays are also stored consecutively in memory. which is advantageous for high performance computing because it is preferred to have data stored near other data that might be used for the same computations. Primary support for compact arrays are stored in a module named array. Primary support occurs in a module that defines a class, also named array, providing compact storage for arrays of primitive data type. How that would be done in Python. How a compact array would be made in Python. I designate the type code. Based on type data types used by the C programming language. The array module does not provide support for making compact arrays of user-defined data types. To create compact arrays of user-defined data types, refer to C types. Okay, we are on 5.3 now, finally. Dynamic arrays and amortization. Okay. When creating a low-level array in a computer system, the precise size of that array must be explicitly declared in order for the system to properly allocate a consecutive piece of memory for storage. For example, 5.11 displays an array of 12 bytes that might be stored in memory locations 2146 through 2157. Yes, we learned that. Because the system might dedicate neighboring memory locations to store other data, the capacity of an array cannot trivially be increased by expanding into subsequent cells. In the context of representing a Python tuple or string instance, this constraint is no problem. Instances of those classes are immutable, so the correct size for an underlying array can be fixed when an object is instantiated. Python's list class has a more interesting abstraction. Although a list has a particular length when constructed, the length class allows us to add elements to the list with no apparent limit to the overall capacity of the list. To provide this abstraction, Python relies on an algorithmic sleight of hand known as dynamic array. Python's list class allows us to add elements to the list with no apparent limit on the overall capacity of it. This is allowed to happen because of a dynamic array algorithm. The first key to providing the semantics of a dynamic array The first key to providing the semantics of a dynamic array is that the list instance maintains an underlying array that often has a greater capacity than the current length of the list. For example, while the user may have created a list with 5 elements, the system may have reserved an underlying array capable of storing 8 object references. This extra capacity makes it easy to append a new element to the list by using the next available cell of the entry. So high level create element list of 5 elements, secretly make a layer make underlying list capable of 8. But when you keep appending elements to the list, the reserved capacity will be exhausted. In that case, the class when exhausted, class request larger list. Hermit crab moves into bigger shell as it outgrows its previous one. We give empirical evidence that Python's list class is based upon such a strategy. We give empirical evidence that Python's list class is based upon such a strategy. The source code for our experiment is displayed in code fragment 5.1 and a sample output of it. Dynamic arrays হুম, তুমি কি চা বানাও? Okay, this they're showing some proof for. Oh, এই যে সকালে খেলো বিকালে খেলবে না। Right time, play in the morning, not in the evening. Okay, we have to learn how to implement a dynamic array. 5.3.1. Okay. Hmm. Oh god, আমি যে ভিডিও বানাইতেছি। হ্যাঁ বুঝছি। Oh, this is not that hard. Thank you. Bruh. Thanks. Yeah, because I'm just reading and I'll put this up. Hmm. I feel like I've read this a while ago. Bro, this is so boring. Okay. Okay. Okay, so after arrays, we learn about stacks, which is used, I guess, like for the undo button that keeps track of text changes in a text editor, or what other web browsers. Oh, there's like a back button. What's a queue? Another fundamental data structure is a queue. So stacks are last in, first out. Queues are first in, first out. And the only the element that has been in the queue the longest can be next removed. Okay, so after arrays, stacks, queues, linked lists. Ooh, ooh. Okay. Yeah, I'm just scrolling through, getting like a high level view of what we have coming ahead. Kind of helps to understand where we are in this whole journey. Damn, bro. This is okay. I think I'm starting to understand what this subject